Hi everyone, I'm volcanologist Dr. Janine Kripner, and this is my guest.
Hi, I'm Forrest Lanning. I'm the Earthquake and Volcano Response Liaison with FEMA in Region 9.
Thank you so much for joining me. And you had a bit of an exciting experience with the Kilauea 2018 eruption. So can you tell us a bit about what you do as an emergency management side of these responses?
So what my duty is to interpret technical information, given that it's either engineering or science, and interpret that to the emergency managers and the leadership within FEMA. Now, with the Kilauea was a kind of a unique situation is because we don't really deal with volcanic eruptions that often. In fact, no one I worked with, at least at FEMA, has in the past. I know Hawaii has dealt with it, but I don't think FEMA was involved in the last eruption. So when the earthquake happened, the first earthquake, the 7.0 earthquake, that's when everyone got alerted. I started getting all these questions about that. And just by coincidence, I happened to be on the Big Island trying to actually understand the hazards from lava flows. I was speaking with the Hawaiian Volcano Observatory literally days before that 7.0 earthquake happened. And when I flew out, that's when the eruptions kind of started and then the subsequent lava flows in the lower East Rift zone. So the biggest concern with FEMA is understanding what is going on, how long will it last, what paths could the disaster take. We want to be able to have a plan in case of any of these worst case scenarios can happen. So what I try to do is try to understand what's going on, basically, as in what the type of inundation of lava, where it can potentially move to, where the lava flows can either go to, or where new fissures can pop up. I also need to understand is how active the summit of Kilauea is, where there were pressure explosions going on almost daily, causing minor earthquakes in that vicinity. And so FEMA and most emergency managers aren't used to dealing with a disaster that is stretched over a long period of time. It's usually just one event, like a hurricane or typhoon, and then you start to respond and recover. In earthquakes, it's usually a main earth shock, and then there's tapering off of aftershocks. It may not be one event, but it's more shortened timeline. So dealing with a lava flow, and when I get the information on how long this could last, and the answer I got from the USGS was anywhere from a couple of weeks to a couple of years. So when emergency managers hear a couple of years, they really freak out. So they just don't know how to deal with that because certain decisions have to be made. There are neighborhoods that were being inundated by not only the lava flows, but also SO2, a sulfur dioxide gas, which is a poisonous gas. And if these neighborhoods are being inundated by this poisonous gas and their houses are technically still intact, but they can't live there. So something has to be done. Either we have to put them up into like temporary housing, or we have to do some type of financial assistance. But the laws are not made up for a situation like that where, well, the gas can turn off tomorrow and then they can move back in, but we don't know when that could happen. So it's a really complicated situation. And basically it's trying to advise leadership on what are the most probable ways this disaster could take. There's also dealing with if the volcanic eruption continues to cause these earthquakes and there was a potential of maybe, I don't know, a slump collapse on the side of the volcano into the Pacific, would that cause a small tsunami around the island? Even though it may have been a very slim chance, we wanted to know the impacts of that scenario. So one of the things was to go out and try to see if we can model it using the assistance of the Pacific Tsunami Warning Center on a tsunami caused by a landslide along the Big Island's coast. And then what other towns on the adjacent islands could be inundated by a tsunami. So we were basically exploring all these different hypothetical possibilities, and knowing what impacts those will have, we will have some type of plan in place, at least thought of, that we could react on if that were to happen. And so it's more of just knowing your options, knowing the possibilities, and having a plan for each of those.
Wow, that's a lot, and that was only one event. Thank you so much for going all over that. I know that was a huge simplification of the enormous process, but it really goes to show how important it is that volcanologists have relationships with emergency managers, local governments, and all of these different aspects of community before something happens. So thank you so much for joining me for this volcano moment, and I hope you have much more gentle events in the future.
Yeah, thank you. It was great being here.